Hello friends, this is your stat sir, your Ravishankar sir. ఈ వీడియోలో లెక్చర్ స్టార్ట్ చేయబోయే ముందుగా మన మంచి మాట. మహాకవి శ్రీశ్రీ గారు రచించినటువంటి ఎన్నో అద్భుతమైన కొటేషన్స్లో నుంచి నాకు బాగా నచ్చినటువంటి కొటేషన్ని మీతో షేర్ చేసుకోవాలని అనుకుంటున్నాను. కుదిరితే పరిగెత్తు, లేకపోతే నడువు, అదీ చేత కాకపోతే పాకుతూ పో, అంతేగాని అలా ఒకే చోట నిలబడి ఉండిపోకు. సో ఇటువంటి అద్భుతమైన కొటేషన్స్ ని అందించినటువంటి మహాకవి శ్రీశ్రీ గారికి హ్యాట్స్ ఆఫ్ చెబుతూ మనం లెక్చర్ స్టార్ట్ చేద్దాం. ఇన్ దిస్ లెక్చర్ I would like to start the fourth part of second unit, which is the last part, that is simple random sampling for 5th semester students. In this part, we are going to learn about the differences between simple random sampling with replacement and simple random sampling without replacement, the merits and demerits of simple random sampling, and also we are going to solve few problems in simple random sampling. First, let us have a look at the differences between simple random sampling with replacement and simple random sampling without replacement. Here is the table of the differences between simple random sampling with replacement and simple random sampling without replacement. All these differences are nothing but the properties of simple random sampling with replacement or simple random sampling without replacement and the results which are proved in the previous videos. So let us have a brief look at these differences. The first one is, in simple random sampling without replacement, each and every unit has an equal and independent chance of including into the sample. Whereas in simple random sampling with replacement, each and every unit has an equal and independent chance of being included into the sample. The second one is, the selected unit in simple random sampling, the selected unit should not be replaced into the population again. Whereas in simple random sampling, the selected unit should be replaced again into the population before going to select the next unit. The third one is, in simple random sampling without replacement, all draws are independent but not identical. Whereas in simple random sampling with replacement, all draws are independent and identical. The fourth one is, in simple random sampling without replacement, the number of possible samples are capital N C small n. Whereas in simple random sampling with replacement, the number of possible samples are capital N to the power of small n. The fifth one is, in simple random sampling without replacement, the probability of selecting a sample of size small n from a population of size capital N is 1 divided by capital N C small n. Whereas in simple random sampling with replacement, the probability of selecting a sample of size small n from a population of size capital N is 1 divided by capital N to the power of small n. The sixth one is, in simple random sampling without replacement, the sample mean is an unbiased estimator of the population mean. Whereas in simple random sampling with replacement, also the sample mean is an unbiased estimator of the population mean. Seventh one is, in simple random sampling without replacement, the sample mean square is an unbiased estimator of the population mean square. Whereas in simple random sampling with replacement, the sample mean square is an unbiased estimator of the population variance. The eighth one is, in simple random sampling without replacement, the variance of sample mean is capital N minus small n divided by capital N into capital S square by small n. Whereas in simple random sampling with replacement, the variance of sample mean is capital N minus 1 divided by capital N into capital S square by small n. The ninth one is in simple random sampling without replacement, since variance is less, efficiency is more. Whereas in simple random sampling with replacement, the efficiency of the sample mean is lesser than in simple random sampling without replacement. And the last one is in simple random sampling without replacement, the probability of selecting a unit at first draw is 1 by capital N, at second draw is 1 by capital N minus 1 and so on. Whereas in simple random sampling with replacement, the probability of selecting a unit at every draw is 1 by capital N only. Next, we will have a look at the merits and limitations of simple random sampling. First, we will have a look at merits. The first one is the personal bias is completely eliminated in simple random sampling since each and every unit in population has an equal chance to be included into the sample. Whenever each and every element of the population has an equal chance to be included into the sample, then there is no question of the personal bias. The personal bias came into the existence if each and every unit of the population has not equal chance to be selected into the sample. The second one is the unknown population parameters can be estimated by using sampling distribution of statistics, that is estimates in simple random sampling. So already we proved in the previous videos that the sample mean is an unbiased estimator of the population mean. The sample mean square is an unbiased estimator of the population mean square. The sample mean square is an unbiased estimator of the population variance, like that. Here, this population mean square and population variance are nothing but the parameters. And the sample mean square are nothing but statistic. So we can estimate the population parameters with their corresponding unbiased estimators of the sample statistics. So these estimates can be estimated easily in this simple random sampling. Next, we will have a look at the limitations. The first one is to select a simple random sample, it requires an up-to-date frame. The frame means nothing but the list of all the population units with the identification particulars. So to select a simple random sample, we need an up-to-date frame, but it is not possible all the times. So a simple random sampling suffers from this drawback severely. Second one is, if the selected sample units are widely spread geographically, then the cost of collecting the data will be more and also time consuming. That means if the sampling units are spread over the area, different areas of a city, or the sampling units are spread over different districts, or the sampling units are spread over different countries, like that. If all the sampling units is widely spread geographically, then the cost of collecting the data will be more and also it takes a lot of time. The third one is, sometimes a simple random sampling may fail to represent the population characteristic due to the reasons of some groups of population may be overrepresented, some may be underrepresented, and some may not represent at all. Suppose, for example, in our college, there are 1500 plus students are there. So, those 1500 plus students are the elements of the population. Now, I need to conduct a seminar in a seminar hall, which is having a seating capacity of 300. Now, I need to select those 300 members from the population of 1500 members. How do I select? So since the seminar topic is mainly useful for the final year students, so that first I'll select the final year students consists of 250. So I selected 250 final year students and I asked them to go to the seminar hall. So they went to the seminar hall and they occupied their seats. So remaining 50 seats are left. Now I asked the second year students, 50 members of the second year students, and asked them to go to the seminar hall. So 50 members of the second year students are also went to the seminar hall and occupied their seats. Now the seminar hall is full. Now in my seminar hall there are 300 members of audience. That constitutes a sample out of 1500 students. So in this sample, we are having 3 groups in our college: first year, second year and final year. So in this particular sample, final years are overly represented because all the 250 members are there from the final year, and second years are underrepresented because only 50 students are there in the sample, and the first year students did not represent at all. So simple random sampling is having this kind of limitation, this kind of drawback. And the last one is simple random sampling requires a large sample size to obtain more accurate estimates as compared to stratified random sampling, which is going to discuss in the next unit. Next, we are going to solve a few problems in simple random sampling. The first one is, consider a population of 5 units with values 1, 2, 3, 6 and 8. Write all the possible samples of size 2 using without replacement from this population. Calculate and verify the following. The first one is, sample mean is an unbiased estimator of the population mean. Second one is, sampling variance is equal to the population variance of the sample mean. Third one is, variance of yn bar is in simple random sampling without replacement is less than variance of yn bar in simple random sampling with replacement. So in this particular problem, we need to calculate the population mean and the sample mean, sampling variance and variance of the sample mean, variance of yn bar in simple random sampling without replacement, and variance of yn bar in simple random sampling with replacement. After calculating all these values, we need to verify this. So let us start the solution. Here we represent the population elements with capital Y. And we are having 5 elements in the population: 1, 2, 3, 6 and 8. Now calculate the total for all these values. One plus 2 is 3, 3 plus 3 is 6, 6 plus 6 is 12, 12 plus 8 is 20. And similarly, now calculate yi square values. So 1 square is 1, 2 square is 4, 3 square is 9, 6 square is 36, 8 square is 64. Now calculate the total of all these 5 yi square values. 1 plus 4, 5, 5 plus 9, 14, 14 plus 36, 50, 50 plus 64, 114. So here we got till now is summation I is equal to 1 to 5 yi value, that is 20, and summation I is equal to 1 to 5 yi square is equal to 114. Also, capital N is equal to 5 here. Population size is 5 here. Now from this, first let us calculate population mean. Let us calculate population mean. This population mean is denoted by capital YN bar, which is equal to 1 by capital N into summation I is equal to 1 to capital N YI. That is, in our problem, summation YI is nothing but 20 and the number of observations are 5. So 20 divided by 5 is 4. Similarly, calculate population mean square. Population mean square, that is capital S square. So the formula for this is 1 by capital N minus 1 into summation I is equal to 1 to capital N YI square minus capital N into YN bar square, which is equal to 1 divided by 4 because capital N is 5 into summation YI square is 114 minus 5 into 4 square, YN bar is 4. That is equal to 1 by 4 into 4 square is 16, 16 into 5 is 80, 114 minus 80 is 34. And this is equal to 8.5. This is equal to 8.5. Therefore, capital YN bar is equal to 4 and capital S square is equal to 8.5. Now we need to draw all the samples of size 2 from the population elements 1, 2, 3, 6 and 8. So for that we are considering a small table here. In the first column we will have sample number, second column sample elements, third column sample mean, which is denoted by YI bar, and fourth column sample mean square, that is SI square, which is given by the formula 1 by n minus 1 into summation I is equal to 1 to n YI minus YI bar whole square, and the last column is small YI bar minus capital YN bar whole square. Now the first sample is 1, 2, second sample is 1, 3, third sample is 1, 6, fourth sample is 1, 8, fifth sample is 2, 3. We do not consider 2, 1 here because 1, 2 and 2, 1 both are same. So sixth one is 2, 6, seventh one is 2, 8, eighth one is 3, 6, ninth one is 3, 8, 10th one is 6 and 8. Now consider the sample means, that means the sum average of these two elements, that is 1 plus 2 divided by 2 is 1.5, 1 plus 3 divided by 2 is 4 by 2 is 2, 1 plus 6 divided by 2 is 3.5, 1 plus 8 divided by 2 is 4.5, 2 plus 3 divided by 2 is 2.5, 2 plus 6 divided by 2 is 4, 2 plus 8 divided by 2 is 5, 3 plus 6 divided by 2 is 4.5, 3 plus 8 divided by 2 is 5.5 and 6 plus 8 divided by 2 is 7. Similarly, on calculating the sample mean square values, that means 1 by 1 into sum of 1 minus 1.5 whole square plus 2 minus 1.5 whole square, that gives me 0.5. So the calculations for this particular column, please do on your own. I am mentioning the values here. I am not going to derive the values here. So I am mentioning the values. You please try on your own. So for the second sample it is 2, third sample 12.5, fourth sample 24.5, fifth sample is 0.5, 8, 18, 4.5, 12.5 and 2. And in the last column, yi bar minus capital Yn bar whole square. That means capital Yn bar is 4 here. So 1.5 minus 4 whole square, it gives me 6.25. Like that, we can get 4, 0.25, 0.25, 2.25, 0, 1, 0.25, 2.25 and 9. Now calculate the sums for last 3 columns. So by adding the values of sample mean, I'll get 40. And by adding the sample mean square SI square values, I'll get 85. And by adding yi bar minus yn bar whole square, I'll get 25.5. So till now we got capital Yn bar is equal to 4, capital S square is equal to 8.5 and summation I is equal to 1 to 10, small yi bar is equal to 40, is equal to 40. One by n summation I is equal to 1 to 10 SI square value is equal to 85 and summation I is equal to 1 to 10 yi bar minus capital Yn bar whole square is equal to 25.5. Now we need to verify the first one. So in this part, we need to verify the sample mean is an unbiased estimator of the population mean. So consider expected value of small Yn bar. That means expected value of small Yn bar is nothing but the mean of the means. So here the formula for the mean of the means is nothing but 1 by small n into summation I is equal to 1 to small n yi bar. And summation yi bar, what we get as summation yi bar here as 40. So 40 divided by, and small n is the number of samples we drawn. So we got 10 samples. So 40 divided by 10 is 4, which is same as capital Yn bar. So that the sample mean is an unbiased estimator of the population mean. Second one. In the second part, we need to verify the sampling variance is equal to the variance of the sample mean. So here the sampling variance is nothing but the variance of all the sample means. So here the formula for sampling variance is 1 by capital NCN into summation I is equal to 1 to capital NCN to yi bar minus capital Yn bar whole square. So which is nothing but 1 by 10 into summation yi bar minus Yn bar whole square is nothing but 25.5, that is equal to 2.55. Now variance of sample mean. variance of sample mean. Here we had been drawn all the samples using simple random sampling without replacement. So we need to calculate the variance of sample mean in simple random sampling without replacement. So that is variance of yn bar in simple random sampling without replacement, and the formula for this is capital N minus small n divided by small n into capital N into capital S square. That is equal to capital N is 5 minus small n is 2, 5 minus 2 divided by 2 into 5 into 85. Sorry, 8.5. Capital S square value is 8.5. That is equal to 5 minus 2 is 3, 3 divided by 10, that is 0.3, 0.3 into 8.5, 0.3 into 8.5, it gives me 2.55. So the sampling variance is equal to the variance of sample mean in this particular problem. And the last one, third one, variance of yn bar in simple random sampling without replacement. Just now we calculated using the formula capital N minus small n divided by small n into capital N into S square. Just now we calculated that 2.55. And similarly, variance of yn bar in simple random sampling with replacement, given by the formula capital N minus 1 divided by small n into capital N into S square, which is equal to 5 minus 1 divided by 2 into 5 into 8.5, which is equal to 4 divided by 10 into 8.5. So 4 into 8.5 gives me 34. So 34 divided by 10, that is equal to 3.4. Therefore, by these values, variance of yn bar in simple random sampling without replacement is less than variance of yn bar in simple random sampling with replacement. This is the first problem. And now the second problem. The second problem is a population of size 3 units with the values 2, 3 and 5. Consider all the possible samples of size 2 from the population in simple random sampling with replacement and verify the following. First one is sample mean is an unbiased estimator of the population mean, and the second one is sample mean square is an unbiased estimator of the population variance, and third one is verify the sampling variance with the variance of the sample mean. So in this particular problem also we need to calculate the sample means, population mean, sample mean square and population variance, sampling variance and variance of the sample mean. So for this, let us try to solve this. Here my population elements are only 3 elements, 3 units are there in the population. So my capital N is equal to 3 here. So the elements in the population are represented by yi. So yi values are 2, 3 and 5. And capital yi square values are 4, 9 and 25. Now calculate the sum of these two. So sum of yi values are 2 plus 3, 5, 5 plus 5, 10. And sum of yi square values are 4, 4 plus 9, 13, 13 plus 25, 38. Now, therefore, sample mean, population mean, therefore, population mean is equal to, is denoted by capital Yn bar is equal to 1 by capital N into summation yi, where I is equal to 1 to capital N. Here summation yi value is nothing but 10 here. So 10 divided by 3, which is nothing but 3.33. Similarly, sample mean square, similarly, population mean square capital S square is equal to 1 by capital N minus 1 into summation yi square, where I is equal to 1 to capital N minus n into yn bar square, which is equal to 1 by 2 into summation yi square is 38 minus 3 into yn bar is nothing but 3.33 whole square. On simplifying this, I'll get 2.36. I'll get 2.36. And similarly, population variance. Which is denoted by sigma square and is given by the formula 1 by capital N into summation I is equal to 1 to n yi square minus yn bar square. That is equal to 1 by 3 into 38 minus 3.33 whole square. On simplifying this, I'll get 1.56. Therefore, population mean yn bar is equal to 3.33. Population mean square capital S square is nothing but 2.36, and population variance is nothing but sigma square, which is equal to 1.56. Now, till now we were calculated all the parameter values. That means all the values regarding the population. Now, we are going to calculate the values regarding samples. First, we need to draw the samples of size 2 using simple random sampling with replacement. So, here sample number, sample elements, sample mean, which is denoted by yi bar, and sample mean square, that is si square, which is nothing but 1 by n minus 1 into summation I is equal to 1 to n yi minus yi bar whole square, and the last column is yi bar minus capital yn bar whole square. Now, we need to draw the sample of size 2 from the population units 2, 3 and 5. So first sample is 1, 1 because we are selecting the sample elements using simple random sampling with replacement. So that's why we may get 1, 1. Second sample is there is no 1 here. The first sample is 2, 2. The second sample is 2, 3. Third sample is 2, 5. Fourth sample is 3, 3. So fourth sample is 3, 2. Fifth sample is 3, 3. Sixth sample is 3, 5. Seventh sample is 5, 2. Eighth sample is 5, 3. Ninth sample is 5, 5. In simple random sampling with replacement, 2, 3 is not equal to 3, 2. Both are different. So, these are all the possible samples of size 2 with replacement. Now calculate the sample mean. So 2 plus 2 divided by 2 is 2. 2 plus 3 divided by 2 is 2.5. 2 plus 5 divided by 2 is 3.5. 3 plus 2 divided by 2 is 2.5. 3 plus 3 divided by 2 is 3. 3 plus 5 divided by 2 is 4. 5 plus 2 divided by 2 is 3.5. 5 plus 3 divided by 2 is 4. 5 plus 5 divided by 2 is 5. Now, on calculating the SI square values, I'll get 0, 0.5, 4.5, 0.5, 0, 2, 4.5, 2, 0. And the last column, similarly the last column, yi bar minus yn bar whole square. That means 2 minus 3.33 whole square, 2.5 minus 3.33 whole square, like that. So on simplifying that, I'll get the values 1.7689, 0.6881, 889, 0.0289, 0.6889, 0.1089, 0.4489, 0.0289, 0.4489 and 2.7889. So now calculate the sum of the last three columns. So by adding the elements of sample mean, I'll get 30. By adding these elements of SI square column, I'll get 14. By adding the elements of yi bar minus yn bar whole square column, I'll get 7.0001. So therefore, till now we got capital Yn bar is equal to 3.33, capital S square is equal to 2.36, sigma square is equal to 1.56, and summation I is equal to 1 to 9, yi bar is equal to 30, summation I is equal to 1 to 9, SI square value is equal to 14, and summation I is equal to 1 to 9, yi bar minus capital Yn bar whole square is equal to 7.0001. Now, in the first bit, we need to verify that the sample mean is an unbiased estimator of population mean. So consider expectation of small yn bar. Small yn bar means the sample mean. So we are going to calculate the average for the sample means. So the formula for this is 1 by n into summation I is equal to 1 to n yi bar, which is equal to, here small n is equal to 9 and capital N is equal to 3. So here summation yi bar is equal to 30. 30 divided by 9, which is equal to 10 by 3, which is same as 3.33. That is nothing but capital Yn bar here. So that small yn bar, sample mean, is an unbiased estimator of the population mean. And in the second point, we need to verify that sample mean square is an unbiased estimator of population variance. So we need to consider expected value of small s square. That is nothing but 1 by small n into summation I is equal to 1 to n small si square. That means the mean average of the sample mean squares. So we are having 9 different samples. For each sample we calculated the sample mean square. So this expectation of s square means the average of all those sample mean squares. That is 1 by n into summation I is equal to 1 to n si square, which is equal to 14 divided by 9, which gives me 1.56, which is equal to sigma square. Therefore, the sample mean square is an unbiased estimator of population variance. And the last one and the third one, we need to verify that the sampling variance, so the sampling variance can be calculated by using the formula 1 by small n into summation I is equal to 1 to small n yi bar minus capital Yn bar whole square, which is equal to 1 by 9 into 7.0001, which gives me 0.78. And the variance of sample mean in simple random sampling with replacement, because in this particular problem we have drawn all the samples using simple random sampling with replacement. So variance of sample mean using simple random sampling with replacement is given by the formula capital N minus 1 divided by small n into capital N into capital S square. That is equal to 3 minus 1 divided by 9 into 3 into capital S square is 2.36. So which gives me, on simplifying, which gives me the value 0.78. So that the sampling variance is equal to variance of sample mean in this particular problem. So we can solve the problems in simple random sampling like this. So with this, we have covered the entire second unit. And in the next video, we are going to start unit 3. So thank you very much and thank you for your patience listening.